So this week we had a guy go out and look at a crane a couple times. And he's one of our sharper mechanics. And he called me and he sent me the faults. And you'll see those in a second. And he said, what do you think I need to look at? And someone else had been out there and changed the fuel filters on it. And it went back to work. And then the problem started again. Pretty much the same problem. And the problem was stumbling, and sometimes the crane would run acceptably, and other times it barely wanted to run. It seemed like at idle, it would run all the time. It would idle okay, but if the operator had to step on the throttle for a heavy lift or something, it didn't have it. So I had him pull all the fuel lines off, check and make sure that fuel would come out of the tank, blow through all the lines, make sure they're clean. He actually did change fuel filters again. There was nothing in the filter. He cut one open. It looked pretty good. The tank was a little bit rusty inside. It's an older tank that's steel, but there was no rust that came out of the bottom when he drained the fuel out of it, put in clean fuel, and we still had this problem. Now you'll notice that there's fuel overpressure faults and fuel underpressure faults. You'll notice that there's an actuator fault, a pressurizing assembly fault. Basically, it's the same thing, that the actuator that controls the rail pressure on this particular engine. And we had a heck of a time figuring out what's wrong because we couldn't see any fuel restriction to the engine. So what would you do? Let's take a look at the faults and then think about what you would do. Then I'm going to come back and tell you what we did and what we found. So here's our list of faults, and at the top we've got 559, which is the injector metering rail pressure is moderately severely low, measured as low from commanded. Next, we've got 2372. There's only 2 counts of that, but that is fuel filter differential pressure, data valid but above normal operating range, moderately severe. Now, differential pressure is the difference between the pressure or vacuum going into the filter and the pressure or vacuum coming out of the filter, or the restriction across the filter is what it is. There's no gauge that measures that. So how does the engine know to log 2372? Think about that. Now, talk about making you crazy. We're talking about low fuel pressure, moderately severe, and then we've got 5 counts of the rail pressure is valid, but above normal range, most severe. That means it's way above commanded. And then you've got 553. Rail pressure data valid but above normal operating range, moderately severe. And you're wondering what's going on here. And then you've got 2311 and 272, which have to do with the fuel pressure control unit that tells the pump, when not to pump, and how much to pump. And those have a couple of faults. But if you look at the snapshot, those faults were not related to this. So I think someone was unplugging and plugging, trying to see if they could get a change on fuel pressure when that was going on. The 1117 at the bottom we're not going to worry about because that was just the customer shutting the batteries off too quickly after he keyed off, and that's what logged that fault. So let's take a look at what the fuel pressure looked like on a graph before we look at the answer. Now this data log that I graphed this out of was just a very short data log where they started the engine up. It was still at the customer's job site, and they tried to rev it up a couple times. They saved the log and sent it to me. But even though it's a short log, it still tells us a story. So the 1911s, what would cause that? Well, the red is measured, the green is commanded. So let's take a look at what happens with the red there, where it jumps way above up to almost 16,000. Next, we can see where the commanded goes up to about 23,000, but the measured never makes it over about 17,000. Well, first of all, the red spikes that go above the green line, if that happens enough and long enough, that will cause your 1911, because the ECM is recognizing that it can make fuel pressure, generally speaking, but there's times when even if it tries, it can't. But there's other times when it'll make too much. So the engineers know that if you get a little bit of air in the fuel or high fuel restriction, you can have these red spikes or the fuel pressure spikes above the commanded. Then when you go to put a heavy load on the engine, the fuel pressure commanded jumps up, to the 20, 30,000 range, so that you've got fuel for horsepower, and the gallon per hour increases and the milligrams per stroke increases, and it's just not there through the pressure tanks. The calibration really decides when it's going to log a fault. And remember, you've got an engine like this in fire trucks, you've got it in marine pleasure boats, you've got them in race boats, you've got them in luggage carriers around the airport, all kinds of applications. And the different calibrations will behave a little bit differently with faults, be a little bit more tolerant or a little bit more critical in terms of how long it waits to log the fault, depending on the application. So here we go. Take a look at the very left. That's the engine operating state. The engine's idling. The crane usually idle around 1,000 RPM, so the commanded rail pressure, which is fuel pressure COM commanded, is usually higher than like in a truck application. So this engine was idling, and you can see the fuel pressure starts to fall off. That's the fuel pressure measured column. And you can see there that all of a sudden it's down to 7,400 and it spikes up to 15,000. And if you let it idle, that's what you would see. This is a very short piece of a short log that I got. And then if you look down where it says on the left, air fuel control derate, that's where the guy stabbed the throttle in the crane and pulled back on the lever to lift up the boom. And the commanded fuel pressure jumped to 23,000, and the rail pressure dropped from 12 to, it jumped to 16 and dropped to 11. And then the engine just started to stall, and the fuel pressure dropped down to 899. It quit running. And you can see in the fuel pressure actuator commanded, that's current column, the last thing you see is 1812, and then you see the 0. When you see the 0, the engine is stopped, it's done, and the ECM has said, the party's over, boys. And you can see the operator still had the throttle at 100%, and then he finally let go of it, and that was it. So on the top right, the arrow is showing basically what caused 2372, 1911, and 553. I don't know that those three lines caused it, but that behavior is what caused it. And then the 2372, we already talked about, the fuel filter. How does it know that? How does it know that the differential pressure in the filter is above normal? It knows it because they programmed it into it to log this fault, because they do all these tests in test cells, and they can make more restriction and make less restriction in the fuel system, whatever they want. And then they study the behavior of the fuel system when it goes under a load. And then they found out that a lot of the warranty claims they were paying on early engine release was because fuel filters plugged up and it had these faults. So they put that in there. People started changing their filters when they saw it, and the problem went away. Now, look to the bottom. That's what was wrong. They had checked the fuel filter, the fuel lines, looked up in the fuel head at the job. Everything looked good. It had 90-degree inlet fitting. They took the fitting out, and in the small passage in there, it was packed solid with rust. And so the mechanic came into my office after he found that, and he's got a smile on his face, and he looks at me and he says, I looked every place on that whole fuel system for a problem. And I said, except And he said, except I didn't pull that 90-degree fitting out because I looked up underneath with the mirror and a light and it looked like it was open. But the problem was there was a corner there and the rust didn't make it around the corner. It got stuck in that little passage. They cleaned that out. The fuel restriction went from 15 inches down to about 6, and the machine ran full throttle, full load, no problem. So thanks for joining me on Engine Shop Joe. See you next time. And it's always going to be the one place you didn't look if you don't find something. Well, most of the time anyway.